Okay, so we've talked about the periodic table and the ions, polyatomics and all of that. And just a reminder, 1a plus 1, 2a plus 2. That means that these guys give away 1 electron, 2 electrons will come over here. Boron, aluminum, they give away 3 electrons. They become plus 3. Carbon does not. I'm just taking that out. Then nitrogen will take 3 electrons, oxygen will take 2, and fluorine would take 1, giving this a -1, -2, -3. So how do we name those guys, though? So let's start with cations. The cations are so nice, especially when they are in the main group and not in the transition metal group. So lithium, for instance, has a +1 charge. The way we name that is just lithium ion. Lithium ion. And this would all be lower caps. I apologize for always writing in capital letters. Let's do the same for beryllium. Beryllium is +2. And it would just be the beryllium ion. Easy enough. So you just take the name, you add ion, and it's all set. The beauty of that, or the reason for that, is because those charges don't change. Oops, that should be 2+. Those charges don't change. Therefore, we can just simply say it's an ion, and anybody can look at the periodic table or just know what the charges are, and they're off to the races. But when we get into the middle, it gets a little hazy. So we have things like iron. Could be 2+, or maybe Fe3+. Copper, it's another one. It can be plus. It can be copper 2+, copper 3+. They're fickle little guys, and they have an ability for different oxidative states, is what it's called. And those oxidative states refer to the charge that they can have. Therefore, we can't just say iron ion or copper ion. We have to define what those charges are in the name. And the way we do that is with Roman numerals. So iron would be iron, let's go with this one, 2. And then ion. And then iron 3. Ion. Same with copper, I'll only do 1. The copper, we'll choose the 2. And 2, ion. Easy enough. So, Roman numerals, when something is in the transition metal area, or can have more than one oxidative state, we need to define what those charges are. And obviously at this point in time, you wouldn't be able to look at a compound and predict what the charge is, but if I told you that copper 2 bonded with, say, chlorine, you would be able to say, okay, and I'm not saying that these two things would, but okay. You would say that means that it's copper 2+, chlorine is 1-, so chlorine is going to get 2, and copper is going to get 1, so it would be copper CuCl2. So I would expect you to be able to do this process, but you're not at the point where you would be able to predict what any of these would be without additional information or something being told to you, but you should be able to name them. So that is cations, and you have to know it can't stay that easy. Anions. Although it hasn't really gotten all that hard yet, because anions, what we're going to do is add "-ide" to the end. So let's choose chlorine, Cl. Take a look at the periodic table. It's in the last column. It's our halide. It's a 7a, so it's going to take on 1 electron, so it's going to be a -1 charge. So it will become, instead of chlorine, chloride. Bromine, we'll take it from the same column. Br, 1-. Instead of bromine, it'll be bromide. See? Not so bad. A little bit more to stick into the back of the brain, but not so bad. Now we're going to get into some polyatomics. Actually, we'll do that in the next video. We'll stop up here.